We now have all the tools we need to solve any stoichiometry problem. So let's get started. Sample problem number 1. How many moles of ammonia can be produced from 7 moles of hydrogen? We want to find the number of moles of ammonia, and we're given 7 moles of hydrogen. So we need a conversion factor to go from moles of hydrogen to moles of ammonia. We want to convert from moles of hydrogen to moles of ammonia, so we're going to need a mole ratio. We know that for every 3 moles of hydrogen in the balanced equation, we make 2 moles of ammonia. So setting up our problem, question mark wanted equals question mark moles of ammonia equals 7 moles of hydrogen dot line. We want to put the conversion factor in such a way that the moles of hydrogen cancel out and we're left with moles of ammonia. So we'll put 3 moles of hydrogen in the denominator and 2 moles of ammonia in the numerator. The moles of hydrogen cancel out, and we multiply the numerators and divide by the denominators, and we get 4.67 moles of ammonia. 7 moles of hydrogen make 4.67 moles of ammonia. Sample problem number 2. How many grams of ammonia are produced from 2 moles of nitrogen? In this case, we want to find grams of ammonia, and we're given 2 moles of nitrogen. We're starting with moles, and we're going to grams of ammonia. So we need to go from moles to moles, and then, so we're going moles of nitrogen to moles of ammonia, so we need the mole ratio. And then from moles of ammonia to grams of ammonia, we're going to need the molar mass of ammonia. So that's our plan. So we need 2 conversion factors. We need the fact that ammonia has a molar mass of 17 grams per mole, and we need the molar ratio. 1 mole of nitrogen makes 2 moles of ammonia, and we get that from the balanced equation. Setting up our problem, question mark wanted equals given. Question mark grams of ammonia equals 2 moles of nitrogen dot line. To cancel out moles of nitrogen, we find the conversion factor that converts moles of nitrogen to moles of ammonia. So we have 1 mole of nitrogen in the denominator equals 2 moles of ammonia. The moles of nitrogen cancel out. Now we need to convert moles of ammonia to grams of ammonia, and we're going to do that using our molar ratio. We know that 1 mole of ammonia in the denominator is equal to 17.0 grams of ammonia. The moles of ammonia cancel out. We multiply all the numerators together and divide by the denominators, and we get 68.0 grams of ammonia. Sample problem number 3. How many moles of hydrogen react with 7.13 grams of nitrogen? So we want moles of hydrogen, and we're starting off with grams of nitrogen, 7.13 grams. So we're going from grams of nitrogen to moles of nitrogen. So we're going to need the molar mass of nitrogen. Then we're going to go from moles, once we convert grams to moles of nitrogen, we need to convert that to moles of hydrogen, in which case we're going to need the molar ratio. How many moles of hydrogen come from X number of moles of nitrogen? So let's get started. We know the molar mass of nitrogen gas is 28.0 grams per mole, and we know that 1 mole of nitrogen makes 3 moles of hydrogen. We set up our problem, question mark wanted. Question mark moles of hydrogen is equal to 7.13 grams of nitrogen dot line. To cancel out grams of nitrogen, we need to put grams of nitrogen in the denominator of the conversion factor. So we know that 28.0 grams of nitrogen is equal to 1 mole of nitrogen. The grams cancel out. Now we need to convert moles of nitrogen to moles of hydrogen using the molar ratio. We put moles of nitrogen in the denominator. We know that 1 mole of nitrogen makes 3 moles of hydrogen. Moles of nitrogen cancel out. We multiply our numerators together and divide by our denominators, and we get 0.764 moles of hydrogen. Sample problem number 4. How many grams of ammonia are produced from 5 grams of hydrogen? We want to know the grams of ammonia, and we're given 5.00 grams of hydrogen. So in this problem, we're starting with grams of hydrogen. So we need to go from grams of hydrogen to moles of hydrogen. And we'll do that with the molar mass of hydrogen. Then we need to go from the moles of hydrogen to the moles of ammonia. To do that, we'll need the molar ratio between hydrogen and ammonia. And then to go back to grams, we need to go from the moles of ammonia to the grams of ammonia, and we'll achieve that with the molar mass of ammonia. So that's our game plan. Our conversion factors are that 2 grams of hydrogen is equal to 1 mole of hydrogen. We also need the molar mass of ammonia, and we know that 17 grams of ammonia is equal to 1 mole of ammonia. And we need the molar ratio between moles of hydrogen and moles of ammonia. And we know that 3 moles of hydrogen yield 2 moles of ammonia. Setting up our problem, question mark wanted, question mark grams of ammonia is equal to the given 5 grams of hydrogen, dot line. We set up our first conversion factor to cancel out grams of hydrogen. So we're going to put the molar mass of hydrogen in the denominator. 2 grams of hydrogen is equal to 1 mole of hydrogen, and the grams of hydrogen cancel out. Then we want to go from moles of hydrogen to moles of ammonia. We'll do that with the molar ratio. We know that 3 moles of hydrogen, we put hydrogen in the denominator so that moles of hydrogen cancel out. 3 moles of hydrogen yield 2 moles of ammonia, and moles of hydrogen cancel out. And we're not finished because we actually want the number of grams of ammonia, so we need to convert 2 moles of ammonia to grams of ammonia. So we're going to put 1 mole of ammonia in the denominator is equal to 17.0 grams of ammonia in the numerator. The moles of ammonia cancel out. We multiply the numerators together and divide by the denominators, and we get 28.3 grams of ammonia. We now have all the tools we need to solve any stoichiometry problem. So let's get started.
I hope you enjoyed this video. To get more chemistry help and a free copy of my Amazon.com best-selling book, Solving Mole Problems, visit purplestoich.com. This is Nalini Fine of Chem in 10. I hope you enjoyed this video. To get